Hey folks, welcome back to ecology in my backyard, or in this case my front field. So this is Solidago canadensis, or Canada goldenrod. Very common, and I think probably everybody's seen it. Has a really brilliant, this time of year is early August, but by late August it'll be a bright yellow inflorescence. Very easy to recognize. The goldenrods and the asters are a family that are very complex genotypically, but also a very beautiful flower. You can recognize them everywhere, and I actually like to see goldenrod. There's another thing about goldenrod that's very interesting, and that is a symbiotic relationship, or maybe a commensalistic relationship, where it has with the goldenrod gall fly larvae, Eurosta solidaginus, and it has a commensalistic relationship in that the gall fly larvae will use the goldenrod, and is very particular for Solidago canadensis, the Canada goldenrod, for a very particular reason, and that is that its salivary, the larval salivary enzymes mimic the plant growth hormone. So let's start off with from the start. And so the mother gall fly will come across and lay eggs on top of usually the top portion of a Solidago plant. And after about 10 days, those eggs will hatch into a larvae. And the larvae will start to burrow into the center stem of the plant. When they get in there, the saliva of the larvae while it's chewing, and again, it's very species specific, it mimics the growth hormone of the larvae, causes the plant to make this gall, this enlargement or winter home for the larvae. So the larvae is going to go in there, and it's quite safe. It's going to develop through 3 different stages. By the time it comes to late fall, and we're not there yet where I am as I'm making this video, but in the next few weeks, that larvae is going to do something very particular. It's going to chew an entrance back from the center of this gall out to the outside. So if you're like me, maybe you've been fascinated by the pharaohs of Egypt and their tombs that they would make. The gall fly larvae pretty much makes itself its own tomb in the center of this, where it's impervious from predators for the most part, although some exceptions we'll talk about, but also from the elements. But just before the fall, you would think he's got this beautiful home. Why would you make a hole in it? Well, he chews a doorway through, because as a larvae he's able to chew this, but as an adult and pupae he's not able to. So the last thing he'll do before it gets really cold in the fall is he will chew an entrance from the center of the tomb, right in the very center chamber, all the way out to just before the epidermis of this gall. And he'll leave just that little membrane there for a doorway. And the reason for that is when he's an adult he can't chew his way out. But within this, over the winter time, he'll be quite happy in his home. And he has another trick up his sleeve, in that this larvae produces a lot of glycerol, which acts like an antifreeze. And the gall will allow some of his tissues to freeze in the winter while keeping others completely liquid, those more critical ones that he can't dehydrate. So he'll spend, wherever latitude you're in, anywhere from 4 to 9 months of the winter time, safe and secure in his home here. And then in the springtime, he will pupate for 2 weeks inside of there, and then after 2 weeks he will hatch into the adult fly, and the adult fly will crawl towards the entrance, but there's still that epidermis of the gall blocking him. So he'll do something pretty cool. I'm not sure how you guys know about hydraulics, but hydraulics can exert a lot of pressure on a backhoe or other heavy machinery by pumping in a small diameter, opening it up into a larger cylinder. You can exert a huge amount of hydraulic force. This fly, as an adult, doesn't have the ability, because they only live for 2 weeks, they don't feed. They can't chew their way out of there. What they'll do is they will pump all the fluids from the rest of their body up to their head, just like a hydraulic pump in a backhoe, and use that swelling head to break through the fairly tough membrane of this home to emerge as adults into the world and reproduce. So it's a very neat hydraulic application that these flies do. The adult flies themselves are not too impressive. They're very weak flyers. If they fall on their back, they can't right themselves. They just kind of stumble around, and they do most of their traveling by walking, so not very impressive as a fly. And in the insect world, much of the life stages for many organisms are actually as a larvae, and the adults are just there to mate and then die, and that's certainly the case for the gall fly larvae. So that's about it for this plant. Great example of commensalism, where one species benefits by getting a house made for it and the other one's not harmed. In this case, it might also go through the winter. Now, wherever you have one, you probably have more of these galls being produced because the adults fly very poorly. So wherever you have one, there'll often be more in this patch. In southern Ontario, where I came from, we probably find 20 patch of goldenrod. Here they don't do nearly as well, so we don't have in southern Ontario. But on my property I've only managed to find 2 so far, so they're really intensive looking, so they're fairly rare. But imagine over the winter time when this is all covered by snow, there's not a lot of food around. Things like chickadees and downy woodpeckers are able to peck a hole, often following that entrance tunnel, that farrow-like entrance tunnel that the larvae has made for it to evacuate as an adult, and they will burrow their way through there and have a nice timbit snack in the middle of the wintertime, very tasty, very nutritious, to get them through. So the chickadees and downy woodpeckers do that. There is another very opportunistic mom of a wasp species, and she's a parasitoid, which means she doesn't parasitize directly, but she lays an egg. And that egg, she has a very long ovipositor, or a long tube that she can lay her babies through, and she will find that entrance burrow that this larvae has made, not as an entrance burrow for the wasp, but as an exit burrow for the larvae as an adult, and she will lay her ovipositor through that long skinny hole, deposit an egg, which starts to eat the larvae as soon as, in the spring, as soon as it hatches. It'll hatch before the larvae and have a nice fresh meal, and then emerge as the adult. So in nature, nothing's ever wasted, and here's a food resource that the gallfly larvae thought as being pretty tricky by making this home for itself, fairly impregnable, but other animals have learned that there's food in there, and they'll take the opportunity to exploit that food resource. So another example of ecology in my backyard, and there's lots of examples in your backyard too, and I hope throughout this course you're going to find them and be interested by them.